Hello, good day. I'm Engineer Technology Squad Nizam from Facility News Recording. Today, I would like to share topics on robotics pioneering the future of industry. Let me share this slide. As we already know, robotics is transforming modern industry. It's bringing significant changes to processes. New standards for efficiency and innovation are being set. Three major forces driving this transformation. First, Industry 4.0, which the rise of digital and smart technologies. Second, advancement in artificial intelligence, remarkable progress in artificial intelligence. And third, global labor shortages, the urgent needs to address workforce gaps. These factors are pushing robotics into the spotlight. Industry are achieving unprecedented levels of automation, accuracy, and scalability. The revolutionary impact of robotics in reshaping modern industry. For example, in manufacturing, robots automate tasks like assembly and quality control. This reduce errors and increase production speed. In logistics, for example, robots streamline sorting, handling, and inventory management. This leads to faster deliveries and improved stock control. In healthcare, for example, robots enable minimally invasive surgeries. They assist in patient rehabilitation, enhancing the quality of care. Advancement in artificial intelligence and machine learning are making robots smarter and more autonomous. This enables continuous innovation and helps meet evolving demands. It also reduces reliance on manual labor. This example of a robotic application in manufacturing, logistics, and healthcare. The key forces driving this robotic transformation, as what I have said just now, Industry 4.0 is driving robotics adoption by enabling smart technology and connectivity, allowing machines to communicate, share data, and optimize process autonomously. Artificial intelligence advancement are making robots more capable, adaptable, and intelligent, allowing them to perform complex tasks precisely and learn over time. Labor shortages are pushing industry to use robots for consistent productivity, especially in repetitive or hazardous roles, reducing risk for human workers. These forces together are accelerating robotics adoption, enhancing efficiency, and raising the standard for industrial innovation. Across the sector, for example, in manufacturing, in assembly lines, robots boost production rates and ensure consistent quality in repetitive tasks. In welding line, for example, advanced robotics arm provide precise safeguard reducing errors. Quality inspection line, for example, with artificial intelligence powered robots, it can detect flaw instantly, minimizing waste and enhancing efficiency. Overall impact for this robotic application in manufacturing industry, which robotics streamlines processes, reduce costs, and improve quality in manufacturing. Okay, let's see this in manufacturing industry.
FANUC robots and factory automation solutions have been facilitating industrial production for over 60 years. FANUC is present in 120 countries, including Hungary, assisting key sectors like the automotive industry, for example at the Audi Hungaria Motor Limited factory in Győr, where they are developing and manufacturing cars for the Audi AG and the Volkswagen Group. Audi Hungary is one of the companies with the largest turnover and export in Hungary, producing 2 million engines and 135,000 cars in 2014.
In our experience, FANUC robots work reliably at our factory. We are constantly improving our production and install robots to reach our targets. In environments where we need to work with high pressure or temperature, the robots are up to the task and deliver quality standards, which would not be possible with human machining. Essentially, robots are used for applications too difficult for humans or where rapid machining is required. Our colleagues like working together with robots as they make human work easier by delivering these tasks. It's very important to program these robots correctly, because when problems arise, it's usually not the robot that causes them, but improper programming or the lack of maintenance. Regarding this, I'd like to highlight that FANUC robots are easy to program, dependable, and we have a very good experience with them.
Now we go to see the in logistic and warehousing, which with this robotic application, efficiency, accuracy, uh, transforming the logistic and warehousing development. Autonomous mobile robot, for example, can handle heavy loads and retrieval, streamlining workflow. Sorting, for example, with AI-powered robots sort items by size, weight, and destination, speeding up order fulfillment. And then autonomous delivery, which robot improve delivery speed and accuracy, meeting customer demands. The overall impact for this robotic in this logistic and housing, which robotics automate repetitive tasks, boost productivity, and optimizes the supply chain. Let's go to see the healthcare industry, for example. In surgical robotics, precise guided system is in complex minimal invasive surgeries, enhance accuracy, reduce recovery times, and improve patient outcomes. Therapeutic assistant, for example, which robot assists in physical rehabilitation, provide customizable exercises that adapt to individual progress. Automation in medical supply chain, for example, ensure timely and accurate delivery of supplies and medication, streamline inventory management, and minimize human error. So for overall impact, for this robotic application in healthcare, enhance care quality and operational efficiency, contribute to be a more effective healthcare system. Okay.
Robotics in healthcare, revolutionizing patient care. The healthcare industry is constantly evolving, and with the advent of robotics, it has the potential to revolutionize patient care. Robotics in healthcare refers to the use of robotic technology in various aspects of the healthcare industry, from surgery to rehabilitation, pharmacy automation to telepresence robots. One of the most significant areas where robotics is being used in healthcare is in robotic-assisted surgery. Robotic technology allows surgeons to perform complex procedures with enhanced precision, control, and flexibility. Robots can be used in minimally invasive surgeries, such as laparoscopic procedures, offering benefits like smaller incisions, reduced pain, and quicker recovery times. Patients who undergo robotic-assisted surgery also tend to experience less blood loss and fewer complications, leading to better outcomes. Another area where robotics is making a significant impact is in rehabilitation robotics. Robotics is used in physical therapy and rehabilitation to aid patients in recovering their motor skills. Robotic exoskeletons and prosthetics assist individuals with mobility impairments, enabling them to regain independence and improve their quality of life. These devices can be customized to fit the individual needs of the patient, allowing for better outcomes and improved patient satisfaction. Telepresence robots are also being used in healthcare to enable remote patient monitoring and consultations. These robots can be controlled by healthcare professionals to interact with patients, check vital signs, and provide medical advice, especially in rural or underserved areas. This is particularly important in the current global health crisis, where remote monitoring and consultations have become essential to ensure the safety of patients and healthcare professionals. Pharmacy automation is another area where robotics is making a significant impact. Robotic systems are employed in pharmacies to automate medication dispensing, inventory management, and prescription filling processes. This helps reduce errors, improve efficiency, and enhance patient safety. With the use of robotics, pharmacists can focus on patient care and counseling, leading to better outcomes and improved patient satisfaction. Robotic prosthetics are also being developed to offer enhanced functionality and natural movement to individuals who have lost a limb. These prosthetics can be controlled by neural signals or muscle contractions, allowing users to perform complex tasks with greater ease. This is a significant improvement over traditional prosthetics, which can be cumbersome and difficult to use. Finally, robot-assisted therapy is being used in therapies for individuals with neurological disorders, autism, or cognitive impairments. Robots can engage patients in repetitive exercises, monitor progress, and provide personalized therapy sessions. This leads to better outcomes and improved patient satisfaction. In conclusion, robotics in healthcare holds immense potential for improving patient outcomes, reducing costs, and addressing the challenges faced by healthcare systems. As technology continues to advance, we can expect further integration of robotics in various healthcare applications, leading to more efficient and effective care. The future of healthcare is bright, and with the help of robotics, we can ensure that patients receive the best possible care.
So advantage of robotics in shaping industry future, it boosted productivity and operational efficiency, higher precision and quality in repetitive and complex tasks, reduced operational costs and minimize labor-related risks, adaptability and scalability to meet evolving production needs. Let's see the agriculture industry.
This is the E-Series robot. The Mega Robot by Agrobot has 24 robotic arms which each pick and harvest strawberries. A mixture of cameras and infrared depth sensors are used to feed the artificial intelligence. The AI can then detect the strawberries' position and ripeness. The robotic arms then cut the stems. LiDAR, which uses lasers, is used to create a 3D map of the robot's surroundings for safety and obstacles. This is a weeding robot that uses short bursts of man-made electrical lightning strikes. Created by the Small Robot Company, the weeding robot works together with another robot whose job is to map every millimeter of the field and monitor the crops. The weeding robot then uses the data to autonomously move around the field, locating the weeds and targeting them with mini electrical lightning strikes instead of using chemicals. Nissan has developed an aquatic robot called Duck. The robot works to reduce pest plant growth in rice paddy fields. Farmers in Asia see ducks as natural allies, since their feet stir up the pond floor, preventing weeds from taking root and growing. Nissan developed their duck robot to mimic this paddling action with a pair of rubber paddles. The robot is powered by solar energy and navigates by GPS. The FarmBot is a CNC machine for plant beds. It will automatically grow plants for you. The FarmBot starts by planting seeds and knows which type of plant is planted in each location. It can then water each one based on its type and age. It can detect and pick out weeds as well as monitor things like soil moisture. No coding is required. The software helps you lay out the optimal plant bed, mixing different types. And the advanced version can automatically switch between tools for different jobs such as seeding, weeding, watering, and soil monitoring. NASA is even looking into how the FarmBot could be used to farm food in space, on the Moon, and on Mars. This is the milking robot called Astronaut by Lilly Vector. It is designed to minimize stress for the cows and reduce the human workload. The cows approach the robot by themselves when they are ready to be milked. The machine recognizes each individual cow from the sensor on their collar, so the milking process can be adjusted according to personalized historical data. And brushes autonomously clean the udders. Iron Ox has created entire year-round hydroponic farms that are run by robots. These indoor farms can produce about 30 acres worth of food on just a single acre of land. The farm is run by 2 robots. One moves trays of plants around, and the second has a robotic arm for manipulation tasks such as seeding and transplanting. The robots also use machine learning and AI to detect pests and diseases, removing plants before they infect others. The Energid fruit harvesting robot uses a frog tongue mechanism to pick fruit. A grid of tongues is moved past a tree on the back of a tractor. When the camera system notices that a tongue is lined up with a fruit, it shoots out and grabs it, just like a frog catching a fly. Virgo is a high-speed automatic picking robot. It can pick any type of crops from tomatoes and strawberries to cucumbers, and Virgo is able to select and pick only the ripe ones. This picking robot by Root AI runs on a track and is able to work in dense greenhouse environments and can work day and night. CNH Industrial have created an autonomous tractor. It works in a field spraying, planting, and harvesting. This driverless tractor can be hooked up to a farm's existing equipment for autonomous plowing or spraying. And it can keep working 24 hours a day, making the most of yearly seasons. Harvest Automation have created the HV100S robot. These robots are used to move and arrange plant pots in commercial growing facilities, such as a large nursery, and they can also gather the plants for seasonal protection. The $10,000 Burrow robot helps farm workers by transporting equipment and crops around the field. It allows farms to pick and pack up to 30% more. The robot can carry up to 500 pounds or 225 kilograms. It uses computer vision and high-precision GPS to follow workers around the field or move crops from the field to truck autonomously. This is the Dino weeding robot by Neo Technologies. The fleet of robots navigate by using 2 centimeter precise GPS and detects weeds using cameras, and then scrapes them out with a specialized tool designed for each type of crop. Agrobot has created this autonomous bug vacuum robot. It uses a double fan vacuum system. This creates a uniformed upwards wind of 35 miles per hour or 56 kilometers per hour, designed to extract bugs but leave the crops untouched. This is the VT-Bot. Developed by Bacchus, it is an electric autonomous vineyard robot. The robot moves along each row of vines, working the soil and removing weeds, and it can work in all weather conditions.
Challenges and future directions for robotics. Challenges in robotic integration. First, high initial cost. A significant barrier to adopting robotic system is the substantial initial investment required. Purchasing and implementing robotic technologies can be financially challenging. Small and medium enterprises, SMEs, often lack in capital resources compared to larger companies. This financial hurdle makes it difficult for SMEs to compete in a rapidly evolving market. Second, the skill gap challenge. Insufficient number of skilled workers trained in robotics and artificial intelligence. Shortage hinders companies' ability to operate and maintain advanced robotic systems. Growing need for training. As robots become more specialized, demand for trainings in robotics, programming, data analysis, the need for skilled professionals in these areas will continue to increase. Therefore, as First University College, we are providing education on this robotics, programming, data analysis from foundation, diploma, degree, master's, and PhD level. The challenges in robotics integration in safety and ethical concern. With the introduction of robots in the workplace, important safety and ethical issues arise with robot integration. These challenges, interaction between humans and robots can create safety risks, especially with heavy machinery. Job displacement ethics, consideration of job displacement due to robots taking over certain tasks. Ensuring safe population, critical to ensure robots can work safely alongside humans, minimize risk to workers in robotics environment. Collaborative robot, or we call it cobots. Expect to see increased use of cobots in the future, designed to work safely and effectively alongside humans. Simplify robotics for industry with limited automation experience. Promote a more flexible and human-friendly work environment. Artificial intelligence about robotics, with AI integration in robotics, making robots smarter and more autonomous. Advancement in machine learning, future robots will learn from experience and improve over time. Enhanced capability, robots will handle complex tasks and adapt to unexpected situations, reduce need for human guidance. Autonomous system mobility, fully autonomous robot increasingly common in logistic manufacturing and healthcare, designed to operate independently with minimal human assistance, highly vulnerable for use in hazardous environment and ideal for tasks involving intensive physical labor. Focus on sustainability and robotics. Robotics will play a significant role in future sustainability efforts, aim to improve energy efficiency and reduce waste, support automation of environmental friendly practice across industry. Even though there are challenges to overcome, like high costs, lack of skilled workers, and safety concerns, the future of robotics looks bright. We are moving towards smarter, more collaborative, and sustainable solutions that are set to change how industry operates all around the world. So the summary, challenges, high cost, skill gap, and safety or ethics concerns. Future potential, growth in collaborative robots, AI autonomous systems, improve productivity and safer adaptable workplace, enhance the ability to optimize energy use and risk reduction. Conclusion: despite challenges, robotics is paving the way for smart, flexible, and sustainable industrial operation, driving global growth and innovation. That's it for my presentation. Thank you for joining me. Bye.